So I want to introduce partial fractions. It's something you should learn in algebra class, but it's usually overlooked because of all the material that's there. But just first of all, consider what we have here. I'm going to add two fractions together. The fractions are 5 over x plus 2, and then we're going to add that to 2x plus 2 all over x squared plus 2x plus 3. And generally when you add these two things together, two fractions, you make a common denominator and then combine all the terms, and you could get one fraction, which I've got here 7x squared plus 16x plus 19 in the numerator, and the denominator is x cubed plus 4x squared plus 7x plus 6. So no matter how many fractions I had, I could add them together to get one fraction. And that's something we're used to doing. Okay, but anything we can do in math, usually there's some way to undo it. So what partial fractions is taking this one big fraction that we created and figuring out how to break it into simpler fractions, usually with the simplest factor denominator. So imagine, if you will, you had a fraction and you wanted to split it up into smaller fractions. Okay, so the question becomes, if you can do that, why would you do it? Well, with the set that I have here, let's say we wanted to integrate this big old fraction. So we were given the big fraction and asked to integrate the fraction that we had, 7x squared plus 16x plus 19 in the numerator, with the denominator of x cubed plus 4x squared plus 7x plus 6. So we look at that and we try and integrate it, and one thing that might come to mind, because the bottom is x cubed and the top is x squared, is a u substitution. But even if I write it out, if you try, let's don't do it there, let's put it below. If we try letting u, okay, so if we try letting the u be x cubed plus 4x squared plus 7x plus 6. Sorry if I'm a little messy there. The du would be 3x squared plus 8x plus 7 dx. And if you look at what we've got for the numerator up here, 7x squared plus 16x plus 19, there's no common factors or multiples that would let us match up this u and du combination. So that just does not work. But if we take the partial fractions and have it split up, we're trying to integrate simpler things. We're trying to integrate 5 over x plus 2. Well, that's a u substitution that turns into a natural logarithm. So that would give me 5 times the natural log of x plus 2. And if I looked at the other one, the 2x plus 2 over x squared plus 2x plus 3, that's another u substitution natural log that turns into natural log of x squared plus 2x plus 3. So we weren't able to integrate the big complicated fraction. Now, just because it's big and complicated doesn't mean you can't integrate it, but in this case you can't. So we were able to turn it into simpler fractions that we can integrate. So the next video we'll look at how to create these partial fractions and do a couple of examples. Thank you.